Okay, now we're going to take all that energy we got coming in and we're going to start talking about another variable, which is going to be temperature. What maybe we need to define what a variable is. It's something that changes value. If you're driving down the road, the distance between where you started and where you want to wind up is constantly changing. That's a variable. Well, temperature is an atmospheric variable that's constantly changing. Heat influences temperature, atmospheric circulation influences temperature, and vice versa. Temperature influences heat, temperature also influences atmospheric circulation. So they work on each other. So let's take a look at a little bit more of this. So what are some of the causes that can change temperature? Well, first of all, every molecule has motion. There's a certain amount of kinetic energy in every molecule. When there's no kinetic energy, we call them absolute zero. And kinetic energy cannot be negative. So if you're measuring kinetic energy, you can't have a negative value. Temperature is directly proportional to that kinetic energy. So the hotter it is, the more the molecules are moving. The colder it is, the less the molecules move. And everything has energy in the atmosphere. All molecules do. And heat is what transfers that energy between two molecules. So when two substances are brought together, they transfer energy between them. And it's always transferred from the warmer, the faster moving molecule object to the colder. So, for example, there's a temperature gradient that exists because of the way the sun heats the earth. Immediately, it's colder at the North Pole than it is at the equator, and vice versa with south and the equator as well. So there's a temperature gradient here. Guess what? The atmosphere is constantly trying to get rid of that temperature gradient. It's feeding energy northward to try to eliminate that gradient. So heat flows in response to a temperature gradient. The greater the gradient, the more the heat will flow. And heat can do this by radiation, conduction, convection, and latent heat. We're going to talk about each one of those a little bit. Radiation we've already dealt with a lot. I'm not going to go into it much more. But it can change the temperature of the air. At nighttime, it gets cooler. Infrared radiation is stronger, and there's less incoming solar radiation. Conduction works. The atmosphere doesn't have a lot of conduction. The molecules are fairly far apart. But things like the ground, it all does. So the air that's right in contact with the ground, right close to it, does have an impact of conduction. Bridges will get heat conducted from above and below it. And a road is on the ground will have heat conducted from below it up into it, and it will lose heat above it. Different types of things change with the heat conductivity. Convection. If you ever watch water boil, you'll see bubbles start to form and go up. That's convection. It's the transfer of heat in a fluid. It happens in the atmosphere when you see these bubbly cumulus clouds forming. That's convection. Except it's even happening all the time, even when you're not seeing those clouds. Some air is moving around, causing convection. Latent heat's a little more complex. The only substance in the atmosphere that can change its state, meaning it can go from a liquid to a solid to a gas, is water vapor. Because of that, and the fact that the latent heat of water is pretty doggone high, matter of fact, it's one of the highest around, it is going to have a major impact on how heat moves in the atmosphere. So, think about it. If you have water vapor, the molecules are a little more spread out. When they become a solid, the molecules are a little closer together. Well, how did we get to that point? heat had to be released from that water vapor to make it into ice. Go the other way. Let's go with you're wanting to make water vapor out of a liquid like an ocean or a lake. Well, the lake absorbs the heat and evaporation occurs. So it had to absorb heat in order to make the water vapor. So all this heat is being exchanged every time in the atmosphere. Wet ground, there's a lot of heat energy going into absorbed by that water, so it can create water vapor. That's why a lot of times the wetter the ground is, the less the air temperature is going to get warm that day. Now, in a cloud, the same thing is going to be happening. You're going to have things going from water vapor. When you see a cloud, there's water. And when that happened, guess what? Heat was released. So that's an interesting thing, that heat is actually released in different when clouds are formed. So all this impacts the temperatures of the air. That's why in a maritime climate, there's so much moisture. You don't find big temperature changes from year to year because the ocean doesn't change a lot. I live right along, not far from the Atlantic Ocean. Summertime temperatures around my area get into the low, maybe mid-70s in the ocean. A little bit warmer once in a great while. In wintertime, they get into the mid-40s. Yes, that's about a 30-degree temperature change. However, temperatures in the summer at my house can be in the 90s. Temperatures in the wintertime at my house can be in the teens or even single digits, rarely, but they have been there. That's a whole lot bigger temperature change. What happens is that climate from the water keeps me from having that extreme as much as some places like you all in Ohio. You don't have a big water source around you. So you're going to have more extreme highs and more extreme lows. I tend to be moderated more, living close to the coast. Here you can see all the wonderful radiation impacts and all. And there are different ways heat's transferred. Sensible heating is because of convection. You might see cumulus clouds. Here is the amount of solar radiation. Notice there's a surplus of solar radiation compared to the actual temperature that occurs down and around the equator. However, above that, there's a deficit from the actual temperature. The reason there is those other temperatures is because air mass exchanges, ocean currents, storm systems. Air masses are just a big volume of air that's all the same. Think about it. If all of Canada, under Canada, you have a lot of snow in the wintertime, very cold temperatures, not a lot of water. So what kind of air mass is going to form over Canada? It's going to be a very dry and a very cold. Now, let's take out in the Southeast Atlantic, off of Bermuda or the Bahamas. What do you have out there? A very warm, moist air, right? Because the water is fairly warm. The air is pretty moist. So you're going to get a tropical air. Very tropical, warm, moist air mass. So the weather is caused by these imbalances of temperature. That is why the atmosphere is constantly trying to get rid of this imbalance. And you can see it. Look at the terrestrial radiation. At night, right about 4 o'clock in the afternoon or so, you wind up getting, all of a sudden it transfers away to more infrared radiation is leaving than is arriving from the sun. Temperature starts dropping. And think about it. The amount of terrestrial radiation is based on the current temperature. Warmer temperature, more terrestrial radiation, so you actually fall faster the first part of the night because the temperature is warmer, and as the temperature cools at night, it doesn't fall as fast because the infrared radiation isn't as strong. So this is just an urban heat island. We have all of those around the country. I mean, St. Louis is famous for one. Chicago has one. DC has one. And I just wanted to show you just a couple quick things here on this. Here is an air mass. Believe it or not, there's an air mass that's developing off Florida's coast, Carolina coast. Temperatures are in the mid-80s. Dew point, which is a measure of moisture, are in the 80s as well. Even this air mass is down over the state of Florida and all. There's a high pressure down there. Now, if I were to move further north, let's see if we can get up to Canada. Well, golly, there's a big high pressure up there as well. Temperatures are in the 50s. Not a lot of moisture around, very dry air. You can see where the air mass is up there. And just giving you an example of how temperature changes during the day. Here is Columbus Airport. We'll just look at temperature. Notice, falls off very quickly at night, rises during the day. Oh yeah, there's a lot of clouds here, I bet, keeping it kind of constant. And then back in the daytime, it picks up, drops back off at night. So you can see the flow of infrared and radiation. I wanted to show you this as well. This is a sounding. This is Cincinnati, Ohio. Notice the bottom, the temperature. It actually cools off the lower part of the atmosphere much faster at night than the upper part. So you'll wind up with actually warmer temperatures aloft sometimes than you do at the surface, especially on a clear night. By the same token, during the daytime, this is in the evening, temperature warms all the way up much further. So you can actually see how the temperature heat is transferred within the atmosphere. So I hope you got a little bit out of this, and let me know if you have any more questions.